FE1A, FE82B, FE82C. Okay? So this is clear. Remember, FE82C or 1A or 1B, we don't use them to share, to forward packets. No, we use them to share information, to learn information about the other networks. Okay? So the next hop for a router is not the IP version 6 of the router, it's the link local IP for the router. Okay? Default route, what's the default route? We define the default route. The default route specifies a next hop router to use when the router table doesn't find any match. So if the routing table of the router doesn't find within the router table any match with the destination IP address, and this packet is not distant to the router or to the local network at this router, the router should use the default gateway, default route, which is 000/0. Remember, whenever you see this one, it means the default route. So if route R1 or R2, it doesn't find a route to R1, and this pocket that's here, it's not distant to this R2, it means it should use default route. Okay? IP version 6, we see this way, the default route, and IP version 4, we use this way. Okay? Structure of a IP version 4 routing table. You know, in classful addressing architecture, we don't use the CIDR. I mean, we don't use, we only use /8, /16, /24, or /32. This is the classful addressing architecture. So this is old version. Then we have to start to add /10. It means that we borrow 2 bits from the host, and we should use them for the network, or /18 or /20. It means that we take 4 bits from the host part and we assign them to the network address in order to efficiently distribute the IP addresses. So IP version 4 was standardized using now obsolete classful. So in the classful, IP address ABC for the classes ABC, we can't borrow bits. We only use /8, /16, /24. Okay, so the IP version 4 routing table is organized using this same classful structure, because there are some networks that still use this classful addressing. They should be contained within the routing table in order to route information for them. So although the lookup process no longer use classes, the structure of the IP version for routing table still retains in this. It means that the routing table still use this classful addressing architecture. Okay. So an indented entry, you make a space, is known as a child root. Okay. A root entry is indented when we indent this root if it's a subset of a classful address. Remember, classful address are with the /8, /16, /24. So directly connected networks will always be indented, and they are child roots. Because the local address of the interface is always entered in routing table as a /32. So if we don't have a slash here, like what? If we don't have the slash, it means that we are in 32/32. Okay. So the child root will include the root source and all the forwarding information such as the next hop address. The classful network address of this subnet will be shown above the root as less indented and without a source code. The root is also known as a parent root. Here, we have this routing table. Okay, so IP root, this is the first IP address. So this is not indented. Here indented. This one, this one, this one, this one. So an indented entry is known as a child. These are the child, okay, addresses. Directly connected, okay. And a root entry is indented if it's a subset of a classful address. So this is a classful address. You see 24, right? It means that it's not /18 or /20, it's 24. And you see here, indented here, it means that this is child roots, okay, till here. This is also another parent, right? This is also parent address, and this is also to indented. You see directly connected. See, this is local, sorry, this is local. This is local. This is also parent because it's 24, 24, 24. And these are indented. It means that they are child addresses. This is also parent, and this is also indented. It means child. So an indented entry is known as a child root. These are indented here. The spaces are child, two child, two child, one child. A root is indented if it's a subnet of a classful address, class A, B, or C. It will be subnet. You know what's a subnet? 0, 1, 0, 0. This is subnet network address. Directly connected networks will always be indented as child root because the local address of the interface is always entered in the routing table as /32. Because you write, you don't add the slash, right? But it is. The child root will include the root source and all the forwarding information such as next hop address. The classful network address of this subnet will be shown above the root entry, less indented if we have this address and without a source code. The classful without source code, okay? The root is known as a parent. So the parent, these are the parents. They don't have this code here, CLO, okay? And this is also parent. And this is also parent, okay? The structure of IP version 6 routing table is almost the same. The concept of classful addressing was never part of IP version 6. So the structure of we don't have this class A, B, C. I mean the classful. We don't use them. So in IP version 6, so it's straightforward as we did earlier. Okay. Here, this is remember, this is the destination. This is the next hop, and we know directly connected. This is the same via. Okay, via, it means next hop. It's the next hop address. And this is the destination, okay? Via here, remember, via here, is to local link. Okay, local link. Okay, this is we are in R1. So R1, this is default. This is default route. This is the cost via FE82C serial 1001. Where's 1001? Serial 1001. It's not clear this. We are at R1. It's not 10, it's 011, I guess. It's error. Let's check. Okay. Interface serial, sorry, 001. This is the default route here, default route. Okay. This is via interface 000. Okay. Okay. This is the configurations of R1 at using IP version 6. Okay. Here we define to see the same. Okay. And this is, we did already that. Okay. Administrative distance. So what's administrative distance? It's the trustworthiness, or it's the الموثوقية. Okay. Trustworthiness. So a route entry, it means that a line within the routing table, okay, for a specific network address, which is prefix slash prefix length, can only appear once in the routing table. However, it's possible that the routing table learns about the same network address from more than one source. Yes, that's true. In the routing table, we can, because the router is connected to several interfaces, and because the different interfaces can use different algorithms or different routing protocols, and the routers can share information, it could be that a router can have proposition for two or three more paths with the same path within the routing table. So, except for very specific circumstances, only one dynamic routing protocol should be implemented on a router. No two, no three. Only one. Each routing protocol may decide on a different path to reach the destination based on some metric. Okay. This raises a few questions. What does the router know which source to use? Which route should it install on the routing table? So when the router is connecting to more than other routers, and the router is only use one routing protocol, so the router should use this information that it receives in order to know which source to use. The interface, to